Gvirotai verabotai, boker tov. And now I will switch to English because this was approximately already half of my Ivrit knowledge so far. I have to apologize. Also being here quite often in this nice country, I still do not really speak Hebrew. CCPP is combined cycle power plants, and this is a power generation technology which emerged approximately 30 years ago from a niche technology to a widely used technology all over the world. And due to the limitation of time, of course, I will not further go in details about this technology. It is also used here in Israel as a main backbone of electricity generation together with the still existing two large coal-fired power plants. I'm from Germany, and you may observe in the media, and I think it was mentioned before here, that in Germany a big debate is going on regarding reduction of CO2 emissions. And there is also a big debate, how can this be achieved? So here in this picture you can see three scenarios regarding what some scientists say about how the global temperature will develop if we don't do anything, if we simply continue as before. This is the upper graph leading within the next 100 years to a warming of 4 to 5 degrees. And there's a consensus, I think, all over Europe that this needs to be avoided. And there are calculations that we need to limit the global warming to below 2 degrees on the long term, and this would be between the middle line and the lower line. And the scientists say that in order to achieve this, we must drastically reduce the CO2 emissions. That means that we have to rethink how we generate electricity. And on the long term, of course, our goal is replacing all the fossil-fired power generation by renewables. And Germany has the goal to achieve this until the year 2050, to have 100% of our electricity generation, and not only electricity generation, but also 100% of the energy usage, for example, in the traffic, by renewable energy. Of course, this will mean that we have to build a lot of new infrastructure for storage of electricity, because also in Germany the sun does not shine always and the wind does not blow always. And you know the situation here from this country. If you want to build any new kind of infrastructure, whatever it is, you will always have people opposing this, normally the ones which are directly affected by it, because also in Germany everybody wants to operate their TV set, but nobody wants to see a chimney or a wind turbine or anything like this in front of his house. So this is an issue which we have, and where the debate in the society how to deal with this is going on. The main four ways to reduce the CO2 emissions, in particular related to energy generation, is carbon capture and storage. This was a big emphasis in public discussion a few years ago. The emphasis is going a little bit down, according to my observation, because more and more people doubt that the CO2, which will be stored somewhere underground, really will stay there forever, and not only just for a few years and then come up again. In any case, we need to increase the use of renewables. Nuclear power is also seen by quite some people, also in Europe, particularly in France and in some northern countries, as a possibility to have a CO2-free electricity generation. However, in Germany, this will not happen in the near midterm and even not in the long future. and in most other European countries, getting a new nuclear power plant through all the licensing and everything would be such a nightmare that nobody would start doing that. This is, however, different in other parts of the world. The third one is improving the efficiency of energy production. And this is by far the way which will show the biggest results in the shortest time. I will come to that. And the fourth one is using fuels which have a lower CO2 emission than other fuels. And this is also something which can be achieved on pretty short notice. Of course, a combination of all these measures is necessary, but what will give the biggest effect in the shortest time? Here you can see what is the CO2 emission. We call it the specific CO2 emission per megawatt hour being produced, so per unit electricity being produced. A coal-fired power plant with an efficiency of 30% emits approximately between 1,100 and 1,200 kilograms per produced megawatt hour. This relates to the two coal-fired power plants here in Israel, the Rutenberg power plant in the south and the Orod Rabin power plant near Hadera in the north. They're still operating, and they have CO2 emissions of more than 1 ton of CO2 per megawatt hour. A new modern coal-fired power plant, which is achieving up to 45% efficiency, they are bigger than the ones which you have here in Israel, is a little bit less than 1 ton, but still approximately 750 kilograms per megawatt hour. Now, a 40% efficiency natural gas-fired power plant, which is a so-called open cycle gas turbine unit, a gas turbine unit without a heat recovery boiler behind it, emits only around close to 500 kilograms per megawatt hour. Why that? Even though the efficiency is not higher than of a modern coal-fired power plant, but the fuel, natural gas, has a big hydrogen content and not only coal content. And the hydrogen out of the natural gas burns without CO2 emission. The emission of burning hydrogen is simply water. And a modern natural gas-fired power plant, like the ones which we build today, has above 60% efficiency, and there you can see that we have CO2 emissions of around 300 kilograms per megawatt hour, meaning that by simply replacing a coal-fired power plant by a modern combined cycle power plant, you save approximately 2/3 of the CO2 emissions. You need to install many square meters of PV in order to achieve that. And the beauty of a combined cycle power plant is that it can run up and down pretty quickly, meaning that once the cloud gets before the sun, these type of power plants will then take over and generate the power which you still need for your air conditioners, because even if there's a cloud before the sun, that does not mean that you will start freezing in your home. So you will want to continue consuming electricity. And this is why I've said that this is by far the most efficient way today of saving CO2. Because although renewable energy, of course, has no CO2 emission at all, while such a combined cycle plant has, yet the amount of CO2 saved per, say, $1 million investment is much higher if you replace old fossil power plants by a combined cycle power plant. Then you can save by installing PV panels, wind turbines. There is not a big market for wind turbines here in Israel due to the wind situation here in this country. For you, it's more the sun. In Germany, it's more the wind, because we have much less sun than you have here, but much more wind. And just last week, there was a press release from Uniper. It's one of the biggest utilities in Germany, which was coming out of the former E.ON, that they are now going in the next few years to shut down their coal-fired power plants and replace them with combined cycles. Although E.ON also invests heavily in renewable energies, yet they also in the next couple of years need to invest in new fossil-fired power plants, which then are combined cycle power plants, natural gas-fired, because on one hand, this is, let's say, the more efficient, cost-efficient way on short term to save CO2, and on the other hand, it's simply needed also in the next 30 years to have an energy production which is fully independent from the weather. And the weather in this case means sun and wind. This is just one example of a pretty modern combined cycle power plant. Has been built by Stadtwerke, which is the local municipality of Düsseldorf, a large town in the northwestern part of Germany. And this is a combined heat and power plant. So it's a combined cycle power plant, gas turbine with heat recovery boiler, and the boiler produces steam not only for driving the steam turbine, but also for providing district heating. In Germany, we have in big cities often district heating, meaning a central heat generation, and the heat is being distributed through pipelines into the houses. Here in Israel, I think this is not really common due to the fact that you here have more issues with cooling than with heating. But in Germany, this is used a lot. And so the combination of electricity production and heat production in winter here is achieving an overall efficiency of above 90%. And this power plant, by the way, is built within less than 1 kilometer distance from places where people live. And this is quite frequent in Germany because in Germany we have a lot of these heating power plants, and even if it's not a heating power plant, in a densely populated country as is Germany, like Israel, you have issues finding a place where nobody sees the power plant. You cannot find such a place in Germany. So in Germany, we are used to build power plants which are clean enough and quiet enough to be installed right at the places where people live. The conclusion of my topic today is, yes, natural gas-fired combined cycle power plants use fossil fuel and therewith emit CO2, but the specific CO2 emission is much lower than any other fossil-fired technology. Since renewable energy sources are by default not 100% available, such combined cycle power plant technology is determined to close the gap between the offering of the renewable energy dependent on the weather and the actual electricity demand due to the high operating flexibility of such a power plant. It is a technology which is mature and available. I've said at the beginning that since approximately 30 years, this is used in a wider scale. So in terms of electricity generation, which is more than 100 years old, the last 30 years is quite a, for us, conservative industry, pretty short period, but it's a mature technology and it is readily available for relatively low cost compared with other energy, particularly renewable energy generation technology. It is in particular also suitable for Israel because, as you are certainly aware, Israel, only during the past 10 years, has found huge gas reserves in the Mediterranean Sea. So within only a few years, Israel became from an energy importer to an energy exporter. The first gas-fired power plants here in Israel have been operated with gas coming from Egypt. Now, Israel has made a contract with Egypt for selling gas to them, because Egypt has had a large investment program in combined cycle power plants, 14.4 gigawatts, 24 of our biggest gas turbines have been installed within 3 years in Egypt. And they are, to a good part, now running on Israeli natural gas. What an interesting scenario. So, new combined cycle power plants are actually the most cost-effective CO2 reduction measure, because, as I have shown, by investing a reasonable amount of money, you achieve a huge reduction of CO2 emission. And it's available today. It's not something which may be available in the future. And the good thing is that such a combined cycle power plant, a modern one, is also fit for the future, because it can also operate on synthetic fuels. This is something which just starts being developed in a larger scale, but excess electrical energy already in Germany now in pilot plants, smaller ones, is being used, for example, for producing hydrogen in a process called electrolysis. We produce also such devices which do this, and this hydrogen can be transported within the natural gas infrastructure and then also burned again in such power plants. It's not only hydrogen, it's also synthetic methane, because once you have produced hydrogen with another chemical process, you can convert it to methane, which is the content of natural gas. So these kind of power plants are also fit for these now just upcoming synthetic fuels. And we have, as Siemens, committed to, in some governmental panel, EU-wide, that within the next couple of years, we will make sure that our gas turbines will be capable of burning also hydrogen as a fuel to a much larger content than it was used before. Up to now, hydrogen as a gas turbine fuel was not really an issue, simply because it was not available on a larger scale as a fuel. But now, since this is changing, we also have a development program of making our units fit for a large content of hydrogen. And so in our small industrial units, this will already happen within the next few years. And in the larger units, which you can see here right now, we at least can burn 30% of hydrogen content, but in the future it's going to be even higher. So this was it, what I wanted to share with you today. I'm showing this here because although the combined cycle technology is not a new technology, it is exactly what is needed in today's scenario in order to, in a short time, cut down dramatically the CO2 emissions of large-scale power generation. Thank you.